So number 8 is x cubed minus xy squared plus y cubed equals 1. If I want to know dy dx, I take the derivative with respect to x of both sides. You get 0 on the right. On the left, I'm going to have the derivative of x cubed minus the derivative of xy squared plus the derivative of y cubed. We're making a very important assumption here that y is just some function of x. So every time you see y, you think function. So here, the derivative of x cubed is 3x squared. But then when we see this, its form is stuff times stuff. So its derivative is going to be, so I'm going to subtract, its derivative is going to be the first times the derivative of the second plus the second times the derivative of the first. And then for this one right here, its form is going to be stuff cubed. So its derivative is going to be 3 stuff times the derivative of stuff because it's the chain rule. So derivative of inside with respect to x. So then if you distribute through this negative, what you're going to get is 3x squared minus x. Oh, but we're not done. Sorry. We need to come in here and say, look, okay, now this derivative with respect to x of y squared, let's signature first, that is going to be 2y dy dx, right? And then it's going to be plus y squared, and the derivative of x with respect to x is just 1. So it goes away, right? And now, so that was first row second plus second to first. Now if I distribute this negative to both of those terms, I get this minus 2xy dy dx plus minus y squared plus 3y dy dx is equal to 0. So now when I look at this, I have, let's see, I have 1, 2, 3, 4 terms. And I need to get all the terms that have a dy dx on the left-hand side. So I'm going to leave this one over here. And I'm going to leave this one over here. But then I'm now going to move the y squared to the right-hand side and the 3x squared to the right-hand side. So I'm going to, from here to here, I'm going to get dy dx on one side. So then from here to here, I'm going to factor out dy dx. So if you factor out dy dx, you get dy dx times, well, there's one common here and here. So if you pull out dy dx out of the first term, you get this. If you factor out dy dx out of the second term, you get this. Y squared minus 3x. So you're going to get y squared minus 3x squared. All that stuff divided by negative 2xy plus 3y is what dy dx is equal to. Cool. And there you go. So the last step is always to divide both sides by whatever is multiplied times dy dx. Okay, so that's 4. The next one we have to do is 10. So 10 is 10 is x e to the y is equal to x minus y. So if I take the derivative with respect to x of both sides, then on the right-hand side, I just get 1 minus dy dx. On the left-hand side, its form is product rule. Okay, so I'm going to have the first times the derivative of the second plus the second times the derivative of the first. So I'm going to have to assume here that y is just some function of x. So when I do that, anytime I see y, I see function, not variable. So that means over here on the left, I actually have x times, and the derivative of this with respect to x is e to the y, but then I have to do dy dx because it's chain rule. And over here, the derivative of x with respect to x is just 1. So now I look and I say, look, I have a dy dx term here and here. I need to get dy dx on one side. So I'm going to put it all over here on the left. So I'm going to have this term, dy dx, what, plus a dy dx? And then I'm going to move this term over this way. So it's going to be 1 minus e to the y. And I'm going to factor out dy dx. So I have a dy dx here and here. So if I factor it out, you're going to get dy dx multiplied by x e to the y plus 1. Then, if you allow me to do this, I'm just going to resize all this stuff. Resize, make it a little bit smaller. Resize it. Then, last step is always to divide. So we're going to have 1 minus e to the y divided by x e to the y plus 1 is what dy dx is equal to. Here to here, we just divide. So if that's 10, and the next one we need is 16. Okay, 16. 16. xy is equal to x squared plus y squared, all that stuff to the 1/2. It's written as square root, but we know that that's just to the 1/2. So if I take the derivative with respect to x of both sides, then on the left-hand side, I say its form is just stuff to the 1/2. So its derivative is 1/2 stuff to the negative 1/2 times the derivative of that stuff. It's just a chain rule. And this is my inside. On the left-hand side, we see that its form is just the product rule. So it's going to be first derivative of second plus second derivative of first. Guess what? dx is just 1, so it's this plus y, and this is 1/2. Leave this alone. But then the derivative with respect to x of x squared is 2x, and the derivative of y squared with respect to x is 2y, dy dx. Okay. All right. So here's what's going to happen. Let's see. I am going to rewrite this as 1/2 square root of x squared plus y squared times 2x plus 2y dy dx. Right. And then I'm going to, let's see, dy dx plus y. Then I'm going to multiply both sides by this to get rid of that fraction because I don't like it. So I'm going to get 2 root x squared plus y squared times x dy dx plus y. And over here I'm going to get a 2x plus 2y dy dx. So there's no easy way to do it. It just seems like this might be the way to do it for now. So let me go back. So now what I'm going to do is take this and copy it. So that means when I go to the next page, I'm going to now distribute, right? So distribute. And so that's going to give me 2x plus 2y dy dx. Over here I'm going to get 2 root x squared plus y squared times x dy dx plus, move this crap over a little bit, plus 2 root x squared plus y squared times y, right? Okay, so that means we're going to now get everything involving dy dx on one side. So I'm going to move this over there, and here's how I'm going to move it. I'm going to change it to 2y root x squared plus y squared. This one's going to stay. So it's going to simply be 2x. This one I'm going to rewrite as 2x square root x squared plus y squared dy dx. And this one I need to move over this way, so it's going to be plus 2y dy dx. So now everything involving dy dx is over on my left-hand side. So I have two terms. So I'm going to factor out dy dx. And who is left behind but 2x square root x squared plus y squared plus 2y is equal to 2x plus 2y square root x squared plus y squared. Notice the beautiful symmetry that often happens in these problems. So now after we factor out, we just divide, which is always the last step in problems like this. So it's this divided by 2x square root x squared plus y squared plus 2y. Cool. Yeah, super ugly, but doable. Okay. So if that's 16, then I have 18, 29, and 77. So 18 is x sine y plus y sine x equals 1. So if I take the derivative with respect to x of both sides using my Christmas colors, the right-hand side gives me 0, but the left-hand side is the derivative of x sine y plus the derivative of y sine x. Y sine x. So both of those, each one of those has the form of the product rule. So the first one is going to be first derivative of second plus second derivative of first. That's going to be this one. And then this one is going to be first derivative of second plus second derivative of first. So the derivative of sine of y with respect to x is derivative of sine is cosine, but then I have to do the chain rule because I need to assume that y is a function of x. And then the derivative of x with respect to x is 1. The derivative of sine x with respect to x is cosine. And then I get this. You need to make it really clear which one's an x and which one's a y, or you'll get confused. That's why I recommend making your y's look like that and your x's look like that. So now I say, do I see all of the terms that have a dy and dx in them? It's those. So that means I should be able to take this and put it here. And I should be able to take this, this, and put it here on the left side. Add those together on the left, and then this one and this one go over to the right-hand side. So I could take all this and copy. And if I move it all over to the the right-hand side, then they're both going to become negative. Right? And so then we know that, so let me take all this and resize it. Resize, make it a little smaller. Then we know that we always factor out that dy dx. Who are we going to have left over here on the left? It's going to be x cosine y plus sine x. Over here we have negative sine y minus y cosine x. And then the last step is always to divide. So we get negative sine y minus y cosine x. All that stuff divided by x cosine y plus the sine of x. Cool. So that's 18. After 18 is 29 and then 77. So 29, it wants us to find the equation of a tangent line. So it says find the equation of the tangent line x squared plus y squared equals all this crap squared at 0, 1/2. And so the picture that makes is, bloop, is that one right there. So I need to go crop. Let's see, I've got this and this. Bam. Okay, so there's that picture. So we are trying, it looks like a butt. So we are trying to find the equation of the tangent line right there. That's what we want. So I know that I have y minus y1 is equal to m x minus x1, where that's my x1, y1. It's equal to m x minus 0. But m is just the derivative evaluated at x is equal to 0, y is equal to 1/2. And so I have to go up here and I have to find dy dx. So that is my goal, right? So I do that by taking the derivative with respect to x of both sides. So on the left, I get 2x plus 2y dy dx, because I need to assume that y is a function, not a variable. It's a function of x. There's some implicit relationship between x and y. On the right-hand side, its form is just stuff squared. So its derivative is 2 stuff times the derivative of that stuff. In this case, stuff is 2x squared plus 2y squared minus x. 2x squared plus 2y squared minus x. So it ends up that I get this plus 2y dy dx is equal to what? 4x squared plus 4y squared minus x times, so now I have to take this derivative. That derivative is 4x. And then this derivative is 4y dy dx. And then the derivative of x with respect to x is minus 1. So now it is just a ridiculous amount of algebra. So this term multiplies by each one over here. It gives me 4 times 4 is 16. So it gives me 16x cubed. Then that one and that one give me 16x squared y dy dx. And this one times this one gives me negative 4x squared. Well, then this one multiplies by each one of these. And it gives me, that one times that one is negative 4xy squared. That one times that one is that's not 4, it's 16. Minus 16 xy squared. This one and this one is plus 4y cubed dy dx. Not 4, it's 16. Why do I keep on saying that? It's got 4s on the brain. And then the last one is minus 4y squared. And then this one multiplies by every one over here. And it gives me negative 4x squared minus 4xy dy dx plus x. Whew. Okay, that is a ridiculous amount of interesting stuff floating around everywhere. So what are we going to do? We're going to look and we're going to find all the terms that have a dy dx in them. Highly recommend maybe using colors. So I'm going to put all those over here. So this one goes over here on the left. Ooh, crap. So this one goes over here on the left. Dude, paste, man. Paste. This one goes over here on the left. This one stays over here on the left. So that's an add. So I've got this term, and I've got this term. And then, so that's on the left. This one has to move over there, so it becomes a negative because I have to move this one that way, so it becomes a negative. This one also has to go that way, so it's going to become a negative. So it is negative this stuff. Put it over here. It's negative that stuff. And then this goes that way. So since it crosses the equals, it also becomes a negative. So it's going to be, oh, it is a negative, so it becomes a positive. It needs an opposite sign. So that's going to be copy, goes over here, and that's a positive, right? Whew. Thank goodness x is 0 sometimes. Okay. Then what? So we've got that term, that term, that term, and that term. So then I guess this one needs to move over to the right-hand side, so it's minus 2x. And then everybody else is left behind. So who's left behind? A negative 16x cubed, a minus 4x squared. You okay?
Yeah.
You okay? Let's see, minus 4x squared. Okay. This one, this one, this one, then minus 16xy squared. This one, minus 4y squared. This one, minus 4x squared. Another minus 4x squared. And this one, plus x. Okay, so this ends up giving me on the right-hand side negative 16x cubed. And then this one and this one give me minus 8x squared. This one and this one give me minus x. This one is minus 4y squared. This is minus 16x y squared. And then over on the left, if I factor out all of the dy dx's, who would be left behind but 2y minus 16x squared y minus 16y cubed plus 4xy, right? And then what is the last step? Always, burp, burp, copy. The last step is always to divide. So let's do that now. So we end up getting this thing, copy, paste, paste. We get this thing is equal to this divided by all of this. Divided by all of this. So that's our derivative.
All right. I'm going to go get the kids.
Okay. X equals 0. X equal to 0. X is equal to... Y is equal to 1/2.
Do the dishes.
Yep.
Make bed.
Yep. When you plug in 0, everything goes away except -4 with a 1/2 squared on top. On bottom, everything goes away except a 2 with a 1/2 and a -16 with a 1/2 cubed. The reason why all the other terms go away is because x has a 0 in it. So that is -1 over 1 minus, what is that? Minus 2? Because 2 cubed is 8, 16 is 2. And so it's -1 over -1, which is 1. Oh my gosh. So we did all that to find out our derivative is 1, which is pretty hilarious. So then we come in here, and that means if we place back in our original one, thus this thing becomes this with a 1 in it, x minus 0. So that means this is the equation of the tangent line. Amazing. Okay, so that's 29. And so if I look at 77, 77, what is 77? No. Come on, man. Oh, yeah, it's backwards on this computer. 77. 77, come on, 77. 77. Press that packaging, packages, okay. 77. So 77, it's saying that, look, if you got, it says, use implicit differentiation to show that the inverse's derivative. The inverse's derivative is equal to 1 over the derivative of the function, plug in the inverse, is what it's saying. So let's see if I can show that. Well, if I've got f inverse, and it's equal to some y, that just means that f of y is equal to x. That's what it means. Do you agree? So if this is true, then this is true by definition of inverse. That's what it means to be the inverse. So now I'm going to use implicit, and I'm going to take the derivative with respect to x of both sides. F of y, right? Use implicit differentiation. On the left-hand side, yay, we just get 1. On the right-hand side, well, first, again, I need to assume that y is just some crazy function of x, that they're definitely related. I would get the derivative of f with y on the inside times the derivative of y with respect to x, right? Are you tracking? But guess what? That means that the derivative of y with respect to x is 1 over f prime of y. But in the very beginning, what did I say y was? Y was just f inverse. So if we go back in here at the very end and plug it in, so since y is equal to f inverse of x, this is just 1 over the derivative of f inverse of x is what is equal to, oh, poop, is equal to, sorry, is equal to dy dx. So we just showed that the derivative of that is equal to that. But guess what? Just to be really clear, if you allow me to come over here. So remember dy dx, if y is f inverse of x, then we just showed that f inverse of x, its derivative is equal to 1 over the derivative, and you see it, right? Is equal to 1 over the derivative with the inverse jammed in there. That's what we just showed. So yay, you're awesome, and you showed that. What does that mean? That means if any time you want to take the inverse and take its derivative with respect to x, all you do is do 1 over the derivative function, plug in f inverse of x. So if they want to know f inverse its derivative at 5, well, then I need 1 over the derivative, plug in the inverse at 5. But what is the inverse at 5? Well, since f of 4 is equal to 5, that means f inverse at 5 is just 4. So we can come back in here, and this is just equal to 1 over the derivative at 4, right? But they tell me that the derivative of 4, it's given, is 2/3. So this is 1 divided by 2/3, which means we get 3/2. And that's it. Awesome. Great work. See you next time.